conversation that we're having about number 12C on the Unit 5 review involves trying to get some relationship between who and what? 7 and 49. Is there a relationship between the two? Why, yes. 7 squared is 49, right? Everybody agree with that? Okay, 7 squared is 49. So this 7 is still a 7. This 49 is a 7 squared. Let's build everything else around that that's already existing. So on the left side, you have 7 to the what? Let's leave that there. Here, 49 is 7 squared, but outside we have an x. Okay. So this is one way of doing this problem. It doesn't involve logs at all. But it could. Right? Good. Now, what do you do with an exponent to an exponent? One of the rules we learned. You do multiply them. So let's make it say 7 to the x minus 2 equals 7 to the 2x. And now we're really close because we got our bases to match. And when the bases match, you can get rid of the bases. You actually can take the bases out of the problem and just set x minus 2 equal to 2x. The bases go away. So just make a new sentence that says x minus 2 equals 2x. And now we have a pretty elementary algebra problem. Take away 1x from both sides, and you're home. If you take away x from both sides, you get negative 2 equals 2x minus 1x. 1x. We have the answer. X must be negative 2. X must be negative 2. That's one way of doing the problem without logs. Now we'll continue the video by redoing this problem using logs. Because that method we just did involves thinking, which is scary to some students because you had to think about what squared was 49, where 7 to the what makes 49, and quite frankly, I don't have time to be thinking. So instead, let's use logs because logs are there for us so we don't have to think. Okay? So it's an operation you can do to a problem in order to get the x out of the exponent. That's why they were invented by me. Because, yes, I invented them. Just kidding. So we log both sides. I had to say just kidding because it's being recorded, and I don't want to get sued by the person who did invent logs. So we can log both sides the same way that you can add something to both sides, subtract something from both sides, square root both sides, take both sides to the second power. You can log both sides. It's a mathematical operation. It even has its own button on your calculator. It's that important. Okay? Once you've logged both sides, there is a rule that states if you have an exponent that is inside a log, that exponent can be free. It can come out of the exponent and go out front. So that x minus 2, the whole thing, is going to go woo, out to here. And this little x on 49 is going to come out front there. So the next line will look like this. X minus 2, that exponent, is now multiplied by the log of 7. When I just say log 7, what's the base? Base 10. We put everything in base 10 because that's the easiest base to use. And then the x can come out front, the log of 49 times the log of 49. At this point, the problem may look more confusing to you, but don't be afraid, because the log of 7 and the log of 49 can just be calculated. You can get the log of 7 and you can get the log of 49 on your calculator. See what they are. I think the log of 7 is 0.845. And I think the log of 49 is like 1.79, 769, okay? Like that? Okay. Yeah, that's right. That's what I was thinking. Now, at this point, we're really close to the answer again. And what we're going to do is we're going to divide both sides by the smaller decimal. We're just going to try to simplify this problem by dividing both sides by 0.845. And you will be amazed by what you see next. These cancel. And 1.69 divided by 0.845 is 2. So we have 2x equal to x minus 2. I'm not sure why I put the parentheses there. They're not really needed anymore. Look familiar? Yes, we just did this a few moments ago. You take away x from both sides, and you get x equals -2. Same answer that we got at about 2 minutes and 45 seconds in this video. Plug -2 into the original problem to make sure that it works. Is 7 to the -2 minus 2? What is -2 minus 2? Is 7 to the -4 the same as 49 to the -2? Indeed. Hence, we did the problem right. And we're done.